Hi, this is Wendy Lightheart, and in this lesson we're going to be talking about the slope-intercept form of the equation of a line. The slope-intercept form looks like y equals mx plus b. When we isolate the y of a linear equation, the equation is then in the form y equals mx plus b, where m is the slope of the line and b is the y-intercept. We call this the slope-intercept form because when the equation is in this form, we can see both the slope and the y-intercept of the line. So here's the slope-intercept form again, and we're going to use this to find the slope and y-intercept of the line represented by the equation y equals negative 3x plus 9. So fortunately, this line, or this equation, already has the y isolated, so we can easily see the slope and the y-intercept. So looking at the form, the slope is always going to be the coefficient on the x after the y has been isolated. And then the constant is the y-intercept. So for this equation, the slope is negative 3 and the slope is 9. Now let's look at another example. Here we want to find the slope and y-intercept of the line represented by the equation 4x plus 5y equals negative 15. Notice that this equation does not have the y isolated, which means it's not in the correct form, so we can't see the slope and y-intercept at this point. So we must first isolate the y before we can identify the slope and the y-intercept. So we'll take our equation and start by subtracting 4x from both sides to get the x term on the other side opposite of the y term. So when we simplify this, the 4x's on the left cancel out and we end up with positive 5y. And on the right we have negative 15 minus 4x. Now you could also write this as negative 4x minus 15. The order doesn't really matter. So then we divide every term by 5 to isolate the y. Now it's important to note that I could have divided the entire right side by 5. But then I'd only have one term. So since we want to have an mx term and a b term, we divide each term separately by 5 to keep those terms separate. So now when we simplify, we have y on the left side since the 5's will cancel out. And then negative 15 divided by 5 is negative 3. And negative 4 divided by 5 we would just write as negative 4/5. If that fraction could be reduced, we would go ahead and reduce it at this point, but this one cannot be reduced. So we end up with the equation y equals negative 3 minus 4/5 x. So now that the y is isolated, you should be able to identify the slope and the y-intercept. So remember that the slope is the coefficient on the x term. So that would be negative 4/5. Notice how I took that subtraction sign with the 4/5 because the slope is going to be negative 4/5, not positive 4/5. So our slope is negative 4/5, and then remember that the constant is the b term, so that tells you what the y-intercept is. So our y-intercept for this equation is negative 3. So the reason why we like to use this form is for graphing purposes, because now these two pieces of information is enough information to graph a line. So let's look at how we would go about graphing a linear equation using the slope and y-intercept. So if necessary, isolate the y to get the equation into slope-intercept form. Do this first. Then you'll be able to identify the slope and y-intercept. The second step then is to plot the y-intercept. And remember that this is the point on the y-axis, 0, b. Then if necessary, write m as a fraction. So if your m is a whole number, you'll just simply write that over 1 so that you can see the rise and the run. And then you'll use the rise over run, starting at the y-intercept. That's a very important part. And you use the rise over run to go from the y-intercept to a second point on the line, and then you plot that second point. So now that you have 2 points, you can use a straight edge to draw a line through the 2 points, extending the line to the edges of the grid, and then draw arrowheads at the ends of the line to show that the line continues indefinitely in both directions. So let's look at an example. Here we're going to use the slope and y-intercept to graph the line represented by the equation 4x plus 5y equals negative 15. So notice this is the same equation we just saw, so we already found the slope and y-intercept of this line in the last example. The y-intercept, remember, was negative 3, and the slope was negative 4/5. Notice that I put the negative on the 4/5 up on top with the 4. So it doesn't really matter whether I put it on the top or the bottom as long as I only put it in one of those locations. So now I start by plotting the y-intercept, which remember is going to be on the y-axis at the point 0, negative 3. Then I'm going to use the rise over run of my slope to navigate from the y-intercept, so we're going to start there at that red dot, to a second point on the line. So the slope tells us with the top number that we're going to go down 4, starting at the y-intercept. So we go down 4 from there, and then the number on the bottom will tell us to go right 5 units. So now we have a second point on our line. So we went again from the y-intercept, we went down 4 and right 5, and then we plotted that point. That gives us a second point on the line. Now you can do this as many times as you want. If the points are fairly close together, I like to do this at least 3 or 4 times to make my line more accurate. But these two are fairly spread out, so I'm going to go ahead and go to my next step, which is to draw a line through those 2 points, extending my line to the edges of the grid and then putting arrowheads on the ends. Okay, let's try this again with a new example. Here we're going to use the slope and y-intercept to graph the line represented by the equation 7x minus 2y equals 16. Notice that this one does not have the y isolated, so we're going to have to first isolate the y before we'll be able to identify the slope and y-intercept. So we can do this by subtracting 7x from both sides to get the x term on the opposite side of the y term. Then that will leave us with negative 2y, because the 7x's are going to cancel out. And then 16 minus 7x, or again you can reorder that as negative 7x plus 16 if you prefer. Now we need to get rid of that negative 2, so we divide each term separately by negative 2. That way we can keep our terms on the right side separated. And then we simplify, so the negative 2's will cancel each other out on the left. And then 16 divided by negative 2 is negative 8. And negative 7x over negative 2 would simplify to a positive 7/2 x. So now you should be able to identify the slope and the y-intercept. So remember, the slope is the coefficient on the x, so that would be 7/2. And the y-intercept will be the constant, so the y-intercept is negative 8. So now we can use these two pieces of information to graph our line. So here we go. We already found the slope and y-intercept of this line, which remember was negative 8 for the y-intercept and 7/2 is our slope. So remember, the first of these two pieces of information we use is the y-intercept, because we need to know a starting point. So we plot the y-intercept first. So that's going to go down 8 units on the y-axis from the origin. Then from this point we're told to go up 7 and right 2. So now we have 2 points on our line. So now we're ready to draw a line through those 2 points, extending our line to the edges of the grid and putting arrowheads at the ends. And that's our line that represents the equation 7x minus 2y equals 16.